Alrighty, let's see what we got here. Okay, easy, solved. Hopefully this will be fast. Given minimum common value, given two integer array num1 and num2, sorted in non-decreasing order, so basically ascending with ties. Return the minimum integer common to both arrays. If there's no common integer, return -1. Note that integer is said to be common to nums1 and num2 if both arrays have at least one occurrence of that integer. So here's 2, here it's 2. Alright, so yeah, this is pretty darn easy. It's basically going to be a 2 pointers. So let's say P1 and P2 is going to be my 2 pointers for nums1 and nums2. And then I just increment the lower pointer. And if they're tied, then I'll return the last. Ooh, nums1. Okay, so I think I'll do something like if nums1 at P1, it should be while. It should be while true, maybe. So it should be in a loop. Yeah, I think maybe I'll do while true. So this is going to increment the lower pointer, if there is one. I guess maybe I should do the break case first. If nums at P1 equals nums at P2, then return nums at P1 or nums at P2, either one. And else if nums at P1 is smaller than nums at P2, then increment nums at P1, because then you want to get to a bigger value. Else increment the first pointer, increment the second pointer. So here the only issue is if they don't have the same, if they go out of bounds. I think if I'm going to go ahead, I'm going to go ahead and put an infinite on both ends. Nums1 append infinite. I was considering appending a -1 at the end, but I don't think it works considering it doesn't order correctly. Yep, so then here says nums at P1 if nums at P1 not equal to infinity, else return -1. I think that should work. Oops, nums1, nums2, nums1 at P1, nums1 at P1, nums1 at P1 less than nums2 at P2. The reason why I do the infinity portion is just to make sure that it never goes out of bounds. And I never have to check for, I don't have to check for this thing going at the end. So I can always increment the index without having to worry about indexing out of bounds. So just backstop to the infinities at the end to return. So summary, this is going to be a classical 2-pointer type problem where you need to keep track of two places or positions in two arrays. Increment the pointer that is pointing to the value that is to the lesser value in a loop. Loop stops when the values at those pointers are not the same. I guess I could have done a while nums1 at p1 doesn't equal nums2 at p2. Yeah, maybe that's slightly better. Maybe that's slightly better. Just the look of it. And then return. Is that better? It's not actually, well, because your conditional still has to compare it regardless, right? If the first statement's false in an if statement, you still have to look at the second conditional. So the first conditional here is just in the while loop instead of in the first branch of their statement. I guess that is the same, okay. And then this return statement becomes the post loop return statement. Yeah, I think this should be fine. It's probably the same runtime. Is that an error? Oh, mistyped it. I'm an idiot. Alright, time complexity, this should be O of n. I guess there's two n's here, huh? O of, I don't know why this thing went slower, it should be the same. O of m plus n, where the size of the arrays are m and n, as in the worst case. The every index within the arrays are processed. Space complexity is going to be O of 1, since no extra space is needed. Alright, cool beans.